Okay, so let's continue from where we left off in the last video, which was the introduction to Pandas Python library. We learned about some of the brief information about the series data structure in Pandas. So let us continue and look at the series data in detail. In this video, you will learn about the structure of series and how to query and merge series objects together. Then we will discuss about the importance of parallelization in data science. We're going to start off by taking a look at how to query a series. To query is a means to get data from it. It is a similar concept to getting values through indexing. We query a series by either the index position or the index label. If we want to query a series object by numeric location, it starts at 0 and we use the iloc attribute. And if we want to query through index labeling, we use the loc attribute. Let's see how it works. I'm going to make a dictionary and pass it to that series function to make a series. Let's print this out on the screen. And now if we want to see, for example, the fourth entry, what we can do is use the iloc attribute and give it the parameter 3. And if we wanted to see what is the value against Alex, then we can use querying by index label and type in s.loc and in the brackets Alex. It is important to understand that the iloc and loc are the attributes of series data object and not their methods. They cannot be used as functions. We cannot query a series using parentheses and instead use the square brackets, or as we call them, indexing operators. Okay, so Pandas helps us make sure that our code is easy to understand and provides the ability to use smart index using the index operator or the square brackets directly on the series. If you pass an integer, it will act like you are querying through iloc attribute. And if you pass a label, it will act like you are querying through the loc attribute. This begs the question that if my index in series is a list of integer, and then I use the smart indexing, what will happen? So let me make an example and type a dictionary with keys as integers. And if I now query it by smart indexing, it raises an error. It returns a long key error. This is because there is no item in the list with an index of 0. So we have to call iloc attribute explicitly if we want the first item. So now let's take a look at how we can perform operation on series. We usually consider all the data inside the series and perform operations on them. Like for example, here we are going to calculate the average of a series object. First we create a series, then apply a for loop and print the average number. Now this is a completely normal way to do it, and it works just fine. However, it is slow, and modern computing demands doing so many tasks simultaneously. And Pandas library alongside its base NumPy offers a method of performing tasks which is known as vectorization. This method works with almost all the functionality provided by the NumPy library. In fact, even the sum function of NumPy uses the same method. Let me quickly demonstrate why the use of vectorization in Pandas and NumPy is really faster as compared to the traditional methods. So I have now created a huge series of random numbers. And if I want to retrieve the first 5 items from the series, I can call the .head method to do so. This is a function that we are going to use a lot, by the way, in the future. I'm going to use a function of Python called cellular magic functions. You don't need to understand how it works, but I'm just going to let you know that it measures the time at which some task is going to be performed. Now let's write the same function we wrote earlier to get the averages. We can see that for each loop it took that much milliseconds. Now let's try with vectorization. I'm gonna write average equals np.sum number and average by len numbers. And now if we run this, we can see that the difference is shocking. Vectorization takes so less time as compared to the normal way. And so the conclusion is that although we already know how to use operations on lists and arrays in a conventional way, by using pandas and numpy, such operations on large amount of data become not only extremely fast, but they also easy to read. Similarly, let's suppose you want to increase each value in series by 2 by the conventional way. First, we recreate numbers series and then apply our loop to increase each value by 2 and then note the time. Then we use a vectorization method and see what's the difference in time. So let's recreate the series and this time just use plus equals 2 to increase each value. Now see the time difference and know that vectorization is significantly faster. And so now let's take a look at how we can change data in series. Let's create a series of people with their subjects. To create a value of a label, let's say to change the value of the label Alex, we can query the log attribute and give it any value we want. In this case, geography, and then we're gonna print the series again. You can see that the value against the label Alex has been changed. And let's now change a value using the iLog instead of log and giving it an index. And then we run it and see the value at first index has been changed. Now let's add a new value. Let's say we want to add another person named Joshua and he studies German. So we write exactly as we did above and see the result. We can see now that since Pandas recognized that this label is not present in the original array, it has added that label with associated value with it to the original series. Interestingly, if I add a number in the labels area, we can see that Pandas adds it to the series without any problems. Even though it's different data type, we have no problems adding more data to it. Okay, now let's see how we can append a series to another series. Let's make two series, people1 and people2. We can append these two series together by using the append function like this. So all people equals people1 dot append people2, and let's print it out. There is an important consideration while using the append, which is the fact that append does not actually change the series object. It instead returns a new series which has the data of both the appended series. And so in this small video, we focused on one of the primary data types of Pandas library, the series. You learned how to query with series with .log and .ilog. That the series is an index data structure, and we learned how to merge two series objects together with append and the importance of vectorization. There is a lot to series objects that we haven't covered in this video, but I will post further information in the form of links because with the current knowledge we can actually move on to the data frame data structure in the next video. And so with that being said, see you all in the next one.